In this and the next couple of videos, I want to talk about a function that takes as input a NumPy array like this, and as output returns a one-dimensional NumPy array. And how we get from the two-dimensional version to the one-dimensional version is we think of each row as representing a digit in binary. So for example, this is like saying 0 times 2 to the 0th, plus 1 times 2 to the 1, plus 0 times 2 to the 2, plus 1 times 2 to the 3. So this is 8 plus 2, which is 10, or this is 4, or this is 8 plus 4 plus 2 plus 1. And every integer can be written in this way, or at least every positive integer can, if you don't want to include signs at the beginning. Okay, so let's get started. So we're going to define toBin. Input we'll call ARR. And just before I forget, let's say return X here. And usually how I write a function is I try it out outside of the function, and then once I get it working, then I put it into the function, maybe one piece at a time. So for example, let's make a NumPy array of random integers between, or that are zeros and ones. So RNG equals np.random.default RNG. Okay, and then let's do RNG.integers. I want them to be zeros and ones, so one easy way to do that is just to put a 2 here. Okay, think of that as like range 2, okay, which would give us a 0 and a 1. Same sort of idea here. And then size really doesn't matter what it is. Let's call it size equals 10 by 4. And we'll call this ARR. Okay, and how do we want to think about it? Well, one way to think about it is that this corresponds to 2 cubed. Okay, it's going to get multiplied by 2 cubed. This corresponds to 2 squared, and so on. So I'm calling this an m by n NumPy array. So let me just define m and n. Okay, this is what's called tuple unpacking. Okay, and if I check what is m, it's 10. If I check what is n, it's 4. Okay, good. And next, I want to have, this is like 2 cubed, 2 squared, 2 to the 1, 2 to the 0. So one way to think about that is this is np.arange. Okay, and it's like we're starting at n minus 1. We want to go down 2 and including 0, so let's go to -1. And the step size should be -1. So for example, it goes 3, then 2, then 1, then 0. Okay, and so it's going down by 1 each time. So these are two different things. This is telling me when to stop. This is telling me how much to go down by. So this should be 3, 2, 1, 0 if I look at it. Okay, great. And now let's raise this, or let's take 2 and raise it to the third, the second, the first, and so on. Okay, so this is 2 raised to this. Okay, great. And now I want to multiply this by 8, this by 4, and so on. Okay, and this should just work automatically. We can do, this is using broadcasting, like we talked about in a previous video. We can do ARR times this. And I don't think I really need it to be in parentheses, but maybe that's safer. Okay, and then how do I get the sums of these? Well, I can use dot sum, and I'm summing like this, so it should be axis equals 1. Oh, and maybe I should have a parenthesis like this. Okay, excellent. So we can just emulate what we did here. And I guess I never used m, so maybe I'll put an underscore here. That's a little more elegant. Okay, and then this is what I want to return. Okay, and let's try it. toBin ARR. Great. Let's try another one. toBin and then np.array. And let me just try some that I can do in my head. 1, 0, and 1, 1. So this should be 2, this should be 3. That's what the output I'm hoping for. Yep, here's 2 and here's 3. So that was one version of this function. We'll do another version of it in the next video, and then in the video after that, we'll add some type checking to make sure the input is really a NumPy array, and also some further checking to make sure the values are really 0s and 1s.